first thing we need to do is figure out what the devil these darn things are doing. So let's go get our DAC assistant. We all know how to get DAC assistants.
Mm-hmm.
We'll drag our DAC assistant out here and go, build me a DAC assistant. You sweet young thing, you. And I want.
Wow. That's not something I like talking
Nice
and slow.
It's
Mine have choice words.
You
It's-
have a
it's-
different relationship with your DAC assistant.
you guys mean you're not? That's obviously why you're having problems.
Obvious.
Then. Okay.
That's obvious.
So now we're going to acquire signals, but we're going to acquire digital signals, right? And we just want line inputs. Okay? We're on the other side of our device. I have device number 5 here now because, and if I look, I got ones that say port 0, line 0, port 1, line 1. On the opposite side from our analog, there's some 0, and I have one that says P00 and one that says P01 over here, so I'm going to use P00 and P01 there. That's the ones I'm going to use. You can use, of course, any you have wires in, and if you don't have wires in, you can use someone else. Now, I get my 2 digital inputs, digital in 0 and digital in 1, which might come from line 0 and line 1. Okay? And I can go see what these darn things do. And let me tell you, they're going to do things differently depending on whether you have one of these white ones or one of the silver ones. Who has a silver one in here? Silver DAC? We all got white DACs?
I think they're all white.
He's got a silver.
Oh, you got a silver one. You're the odd man out. Yours is going to behave differently.
You want those at the
Okay.
end?
Okay, so I have this perfectly good thing here, and when I have something that says digital in 1 and digital in 0, and I can do something really radical like say run here. And when I say run, I go, ooh, it says I have signals there. See the little lights light up. I go, okay, that's kind of good, that's kind of cool. And all of them will do it except Todd's, but that's okay. He's gonna be the odd man out today. So, okay. So I'm gonna go say, okay, I've got this perfectly good signal here. I'm gonna chug through here and I get my DAC assistant. And it's gonna what I wanna do with this DAC assistant. It's not gonna tell me anything this time. And I'm gonna have to go put it in a structure because I'm gonna need a structure. So I'm gonna go put it in a while loop. Okay. And then I'm gonna go, my while loop's gonna complain because I don't have a stop button. So I'm gonna go get a stop button and drag a stop button somewhere off and wire up the loop condition because, yeah, you gotta wire the loop condition so it's happy. And then I wanna look at these guys, so I'm gonna come over here to my front panel and get some booleans. Let's see, we want round lights or square lights?
Square.
How do we feel like? We like
Round.
Round.
Okay.
Can I do one of each?
Sure.
Yes.
Why not both?
Okay, we'll do one of each. Okay, so I got round buttons, which I'm gonna say as, let's say as channel,
Where do we go after digital?
what, channel A,
Look.
right, just sort of arbitrarily.
Oh, just go next,
And then I'm
please.
gonna get, because I've got complete disagreement in this class, nobody can agree on anything.
Complete disagreement.
Okay, can't agree upon whether we should have squares or rounds. Am I wrong on that? Okay, so I got buttons that are channel A and channel B, or not buttons, lights.
Yeah.
Because I like to know when I'm gonna get the lights in. Let's get these out of here. Now, I'm one of those guys that's thinking, what am I gonna do? I'm gonna get 2 channels of data. If I try to wire these data up here, it's gonna go, no, no, no. The type of the source is array. The type of the terminal is Boolean, so I'm getting an array in, because I'm gonna get an array of however many digital inputs I need. But we know how to get things out of arrays, because
We done that before.
we've done it before. So we go to array, index array, come over here, blow away these lines that aren't looking any good, right? Right, hook up our index array here, right, run this out to here, it goes, oh yes, I'm happy, I'm big thick line of booleans. I'm going to make this down and make another one there. Go get numbers. I like numbers, okay. I'll get a 0 and make 1 a 1 and hook it up so I index 1 0 and index 1 1, and I'm going to say that channel A is the 0 1 and channel B is the other guy. Okay?
Is that 0 and 1?
Yep.
Okay.
0 and 1, because we're just indexing the 0th thing out of the, I have an array with 2 things in it, right? Because there's 2 channels. And so I do that, okay? So, that's complicated programming, isn't it?
Gonna get worse.
You're trying to tell me that after 7 weeks, you're wise to my tricks? Or is it 27 weeks now?
Yes.
Yeah.
Yes, it's the 27 weeks, you're
27.
wise to my tricks. Okay.
I really hate how you can't zoom in on this thing.
Isn't it annoying?
Yes.
It is, the number of people that requested, you should go look at Zoom in LabVIEW and the number of people
Oh,
that
I'm
have
sure.
requested Zoom in LabVIEW, it's one of those, yes. I'm sure there's some structural reason why they haven't done it, because they've been requested, the number of times they get requested is sort of countless. So, okay, now, I have I'm gonna go, I've got this all hooked up here, and the first thing I'm gonna do is go, what the devil is it doing? So I'm gonna hit run over here, because run is cool, and what happens is I go, huh, that's kinda crazy, because my lights are on.
It's all green.
And I'll bet, to tell you that, I'll bet everybody's lights are on, but Todd's.
I only had one
Yeah.
light on.
You only have one light on.
I'm on the wrong one, I got it.
Okay, so.
I see my
You
problem.
see your problem, yeah. So everybody's gonna have 2 lights on, but Todd, who's gonna have no lights on. Cause his is silver. Well, he's special.
What mother tells me.
Okay, so I can bash Todd now, right? So I was bashing Sheldon earlier, bash Todd. Sophie's not wanting to look at me anymore, so I can't bash her anymore, so it's.
Now you keep stealing her components. You can't bash her.
Yeah.
I do, okay, so I keep stealing her parts, but I gave it back,
Yes.
okay. Okay, so, now the interesting thing is these are on, and I'm kinda like going, I don't have anything hooked up. In fact, I don't have these hooked up to
Anything.
anything,
No,
so, and they're on.
no.
Wow.
Going, oh, yes, let's see, let me go somewhere in here, maybe dig back in my ancient history, long ago in a galaxy far, far, far away.
We're
Did I
talking
get
Big
far enough
Bang or
away?
dirt?
There was a 6009 user's manual.
Just 2 bowling.
Uh-oh, I'm going to
Just 2
actually
bowling.
RTFM.
He had 2.
Read the fucking
Yeah,
manual.
because they just collection. Let's go back to the dApps, where you create the dApp.
This is cool. Where is this at? Is this on Blackboard? Can I download this somewhere?
You want me to download, I will post
You need
the,
to select
I will
0,
post
0,
it to
0, and 0,
Blackboard.
1.
How about that
Control.
for you?
Sweet.
Select.
Okay. Oh, crap. Of course it does that to me. So let's let's see, instrumentation, there we go.
Yeah.
I've got too many things on my blackboard. Does your blackboard look as bad as mine?
No, go back.
Okay,
Window.
so let's do,
You still have-
Okay.
NI, 6008 user manual. Okay. And I'm going to go find these NI 6008 users manual, because I wouldn't want anybody to be without a manual. Okay,
You have to read it.
RTFM.
So great.
There is a story that goes with that.
I'm sure there is.
It's actually almost as good as, so there's even the manual on the interwebs. Anyway, if you look at the manual, here we have the
Sweet.
manual, and I can actually zoom in on it because it's
Okay.
like
Everything else except for GladView.
no, everything else except for audio is. And I can even go out here to where it says digital input and output on the manual. And it goes, it has
Oh, they
12
have
digital
Chinese?
lines, right? Okay, that's digital outputs, right? 0 to 7 and 1 to 3, so you've got all these digital inputs and digital outputs, right? And we notice that we've got digital inputs and digital outputs. Those are kind of cool. Digital inputs, this one here, some TTL signal, digital input here. This is kind of an interesting one here. It's switched, and what are they switching it to there? They're shorting it out to ground through a resistor. So let's go look at these a little bit more. Okay, source sync information. The default configuration of the NI USB 608, 609 digital input panel is open collector, allowing 5-volt operation with an onboard 4.75K pull-up resistor. Okay, so this is the box here. This is our input port that we're hooked to, and it has a 4K resistor here. This is very high impedance. It doesn't wanna push any current through there. So what's this for? If there's no current that's flowing this way, and there's no current flowing out this way because it's sitting out here in space and not going anywhere, okay? That makes a pretty high impedance circuit that way. What's gonna happen to this port? Well, it's gonna get pulled high. Okay, so how do you change it? Well, you short it to ground. What happens when you take this pin and ground it? Well, you got 5 volts, about a 5K resistor, that's gonna be a milliamp of load, right? 5 volts divided by 5,000 ohms basically is a milliamp, right? A little bit more than that, not very much, right? So that's not gonna care, it's gonna go out to ground. So these look like they need to get switched by being connected to ground. And I can go try that and see if it's actually what's working, because I can take my wires and I can go, where's ground? Oh, there's ground over there at the end. And if I short out ground, one of my
Lights go on.
lights goes out. And if I short the other wire to ground, my other light goes out. So, I understand how the pins are going. Now, if I was to do something real crazy, like go this 6001 user's manual, okay, and go to digital I/O, right? They have almost the same picture, except that, okay, except that now, when you look at them, what are they done? Internally, they have a 4.7K pull down resistor.
47.5.
Yeah, 47.5K pull down resistor. That's the output actually port. Where's the input port? Sorry, input port. So the other ones here, okay, these guys here,
I know.
these guys over here, if you have a 6001, which they do, is they're going to work the output. So here it is, at hardware states, set all the digital I/O lines to high impedance inputs. The Mech device does not drive the signal high or low, and each line has a weak pull-down resistor connected to it. So yours, Todd, which is a 6001,
Okay.
if you flip over the back, you can look at it. It's a 6001. Yeah, maybe so. It instead of having a pull-up resistor, it's got a pull-up-down resistor. So how do you make yours lights? Well, you go down and take the wires along the edge, then there's a place that says 5 volt. And if you take those wires and touch them to 5 volts, they'll work. Okay, there's a line down the one that works for 5 volts. So yours works the opposite of the white ones. The white ones work one way or the white ones another. So, okay, I now know how my digital inputs work. Okay? And so now I gave you encoders. So, what the devil do these encoders do? They got 3 wires. What do I do with them?
One crown.
I got 3 wires, right? Okay? I got 3 wires, so what am I gonna do? Well, I need 2 signals, right?
Yeah, two signal, yeah.
So it's, what am I gonna do? So, well, ooh, maybe we should find some documentation. Okay, so of course I go browsing off on the interwebs, and somewhere out over there, somewhere I found something about a 12 millimeter encoder data sheet. Okay, and I don't know, that sort of looks like ours, kind of in a funny sort of way. 12 millimeter encoder, pull and push on shafts. Okay, it's got quadrature outputs, and it looks like the output signal format is, okay, I've got 3 wires. Now, let's think about what I've got for 3 wires. If this was optical, if this was an optical encoder, how many wires would I need? Well, I need to power the lights, right? Because I need a power for a light source. So that's going to be 2 wires, right? I have to have a positive and a negative just to get to power the light. And then I need 2 wires for signals, because I'm going to need a signal to ground each one. So I'd need 4 wires, right? I don't know any way around that.
Anti-clockwise.
Right, yes, well, counterclockwise, anti-clockwise, we say
Never
it.
heard of that.
Yeah, we can use the language in funny and bizarre ways.
Huh.
Who knows who's writing this, right?
British, the Union anti-clockwise.
Anti-clockwise are the British?
Counterclockwise.
Well, or someone who learned their English skills from the Brits, right? Okay, so we can blame it on the Brits, or maybe we'll blame it on the French.
You can always blame
You can always blame it on the French. Okay. So we can always blame it on the French. That's always a good thing. Okay. So now my suspicion is that given there are only 3 wires, I don't think there's a light in there. And when I see things in here that go like terminals A to C, I'm getting a pulse. Terminals B to C, I'm getting a pulse. Okay. I'll bet these are a switch. Just a mechanical switch. Because of course, would your instructor buy ridiculously expensive encoders?
No, not for us.
No, I wouldn't buy ridiculously expensive encoders, because, yes, so these are probably cheap eBay encoders. In fact, almost certainly cheap eBay encoders, because that's what your instructor does, right, is buy cheap eBay stuff. So, okay, so anyway, these are 12 millimeter encoders. They even have funny little buttons. You push on them, a little switch, you push on them.
Oh, it does.
Right? Yeah, it does. You know what these are for, actually. these are in all probability for the volume knob of your radio in your car, right, or something else. You know, you have the button, you push on it, right, and then you feel the detents when you turn it up and down, right? Because they're all digital these days, right? They're not doing it analog anymore. They're all gone to digital. So that's what I'm sure these were for. But hey, they're an encoder. They'll work because they have to be able to tell when you're getting louder or quieter, right? Got to be able to tell the same thing. And they don't care where you are when you start. You can keep spinning them around forever, which we all do these days, right?
Makes sense.
If you turn them too fast, they lose counts, right? All the other things.
Depends on how old you are.
Yeah, there's that. Okay, I want to. So my guess is these are a switch, and I guess these are a switch that's switching from A to C and switching from B to C. Okay, which? Okay, Abe. Okay, which leaves me one question. Looks good. Okay. That's good. Thanks. Just you have a good one. We'll see you next week. Okay. So the question is, what's A and what's B and what's C? Now, I could probably go play with an ohm meter, but I'm not sure. It'd be kind of hard to tell, right? Which one's A, B? I mean, there are switches. It's hard to tell which side of the switch you're on, right? That's kind of a pain in the neck. So let's, well, we got a data sheet. Let's scroll down. What's the data sheet? Okay.
The yellow one's the
Okay.
alpha.
I have data sheets. That kind of looks like it, right? That kind of looks like it. Oh, I have data sheets. Oh my goodness. I have data sheets.
Nice.
And I can zoom in on the data sheet. And what do I see over here? It says A, B, C. Right, and so the C one is going to be in the middle.
Middle. And how do you?
Okay, and so how do you tell which one's the middle? Well, you look at what color they are.
The yellow.
I have black in the
Mine's
middle.
black.
Mine's black.
Yeah, I have black in the middle. I have yellow on one side.
Okay, whatever.
Why don't you look at
Yeah, that's a black.
look at them down here.
Oh, okay.
Okay, look at them down where the pins are, right?
Yes,
Right,
yes,
because
yes,
who
yes,
knows
yes,
what somebody did with heat shrink tubing, right? So okay, it looks like here we've identified them. A is on one side and B is on one side. We don't really care, and C is